some are absent over there.
I'm charging my phone. Sorry.
It's okay, it doesn't matter, I know all your names now, so it doesn't matter, but, Quentin, is still not here.
He'll be back tomorrow.
Okay. Who else? Are we missing anybody else? Alex is here. Olivia and Mary Margaret are both gone. Okay. I knew Mary Margaret would be gone. She's gone for a long time. Everybody else is here. Okay. So here we are. We're on review 2.1 to 2.5. And it starts with write the equation of. So the first one is linear function where f of 2 is 3 and f of 1 is -4. All right, we had a quiz over this, right? What does this mean?
It's
Ordered pairs. So this is 2, 3, 1, -4. You're writing the linear function. So when you even see those words, what pops into your head? Y equals mx plus b, right? So what's step 1?
Slope.
Find the slope. So slope is going to be -4 minus 3 over 1 minus 2. It looks like the slope is 7. Right? Then what do?
You plug in.
Pick a point.
You pick a point and either do slope intercept or point slope, whatever flips your switch, but somehow you gotta find b, right? So I like to point slope, so y minus 3 equals 7 times x minus 2. So y equals 7x minus 11. That's what you should end up with as the answer. -14 plus 3, -11. All right, everybody good with that? We should have missed that one. Now, this one's much harder. Not hard, but definitely harder than that. Here are our roots. How do we build an equation from this? Well, it's going to be y equals, yep, for sure. You got to make the, exactly, you need to mate for 3 plus I, and what will that be? 3 minus I. They're not going to tell you that, or I'm not going to tell you that. You need to know that complex roots come in pairs, always. So if you have a 3 plus I, you're going to have a 3 minus I. Now, how do you build the equation? Where did that come from? When you factored your problem, remember when you were guessing numbers and you put them in and you factor your problem? Where did that come from? X minus 2. So there was a factor that was x minus 2. And similarly, there are 2 more factors. Move everything over with the x. It would be what? X minus 3 minus I. And this one is x minus 3 plus I. You're moving everything over here with the x, just like you move this over. Now what do? We FOIL it out, and it really doesn't matter in terms of your answer, but I think it's always easier, even though they're bigger, to start there, because since those are conjugates, a bunch of it will cancel out for you. So here we go. My personal style is I take x times all of those, so I get x squared minus 3x plus ix. And then I move over here and I take this times all those, minus 3x plus 9 minus 3i. And then I take this times all those, minus ix plus 3i minus I squared. lots of numbers. But the good news is, as you look that over, what do you notice about it? You're gonna lose the IX's, they're gone. You're gonna lose the 3 I's, they're gone. These two add together, so you have x squared minus 6x. And what about this? Negative I squared.
1.
It's a positive 1, which will add to your positive 9. So even though that looked like a lot, it boiled down to this, which still needs to be times by the x minus 2. So now I start over. I'm going to take this times all of those. And then this times all of those. And then I'm ready to say y equals. This is my equation. Somebody said y equals. Yep, y equals what? X cubed minus 8x squared plus 22x minus 20. There it is. There's the polynomial that if you solved it, you would get these answers. So what's the key? Build the factors. Multiply them together. Now we're going to write another equation. This one is a parabola. Now everybody knows that this is the type of equation we are looking for, right? That's the equation of a parabola. So if you are told that the vertex is at 1, negative 4, what can you tell me about your equation? If you know that's the vertex, it's going to be x minus 1 squared minus 4. And the only thing you don't know is what that coefficient there is. But you can figure that out because they gave you another point. So we put the negative 2 in for the y and the positive 2 in for the x. And we figure out, okay, that's 1n minus 4 is n2. Double check my arithmetic, I think that's right. So then my answer would be 2x minus 1 squared minus 4. That was on a quiz. Hopefully that's not like looking strange to you. Number 2. Describe, oh, by the way, this is assigned homework. I'm kind of doing it for you, so maybe you want to be writing it down. Describe how this function compares to the parent function, or your BFF, y equals x squared. Are they both parabolas? Yep. What's changed? First it shifted. It's now vertex where? Left 1 and down 9. So you moved left 1 and down 9. What else have you done? You've stretched it vertically, right? So instead of like a normal parabola, this one rises faster because you've times the y's by 2, the verticals by 2. Find the quotient and remainder. Okay, so what are we going to do if we have to find a quotient and a remainder? Divide. You're going to do a division. It doesn't matter how you divide. I'm going to use synthetic division. So I'll put a 2 out here in the box. Oh, be careful. You see what I'm getting ready to warn you about? You need to put in a negative, or excuse me, a 0. You're missing an x cubed term. Do you see that?
Yep.
If you don't put in a 0, you will not get the right answer. Pay attention. You know I'm going to try to trick you. So now I'm ready to go. 2 times 3, 2 times 6, did. All right, I don't know. Double check that arithmetic. How does that look? Okay, so I don't know exactly how this will be asked, but if it says what's the quotient and what's the remainder is easy. The remainder is 69. This number is the remainder, right? We hope in a lot of our problems that's 0, because what does a remainder of 0 mean? We have a factor. Well, obviously 2 is not a 0. X minus 2 is not a factor. It leaves a remainder of 69. What's the quotient? 3x cubed plus 6x squared plus 21x plus 34. That's your quotient. And then your remainder is the 69. You can either write 69 or you can put 69 over x minus 2. That's up to you. It doesn't matter to me. Both are going to get full credit. I couldn't care less. Now, one more point I want to make has nothing to do with this problem, but it just happened. You see how everything down here is positive? What does that mean? We have an upper bound. 2 is an upper bound. Remember those rules? If you've forgotten them, get your notes out and remember them. Okay? If you do the division and the entire row turns out positive, you have an upper bound. That's not part of this question. I'm throwing that in as an aside. All right, number 4. Find the remainder. Okay? Now, I know what some of you are thinking. You think, oh, another division problem. I don't think you want to do that. Right? Look at that power. I don't think you want to be doing division. I know I don't. So what am I going to do if I just want to know what the remainder is? I don't want the quotient. I just want the remainder. What am I going to do? Plug in. What am I going to plug in? -1. I'm going to plug in the same number that I would have divided by. So if you were going to do a division on this problem, wouldn't you put a -1 out here in the box? Plug that number in. So plugging in a -1 will give me a 3 plus a 4 minus 10. I got -3. There's your remainder. That's all there is to it. You want the remainder? Plug in the number you divided by. Now that will not give you the quotient. The only way to get the quotient is to do the division. But if all you want's the remainder, you can plug it in. Is x plus 3 a factor of this, y or y not? X plus 3 is the question. Is it a factor? Well, how are you going to tell? What? You can do division. And if you do division, you're going to divide, and that better come out to be a 0. Or you could also do what? Plug in -3, and this should all equal 0. In this problem, it doesn't matter. Do whatever you want to do. If that were a 300, then I sure as heck wouldn't be doing division. But since it's a 3, go ahead and divide, if that's what you like to do. I'm going to plug in -3. Remember, that's the number that would be in the box, so that's what I plug in. So when I plug in -3, I get 0. So the answer is yes, it's a factor. Why? Because the remainder is 0. That means you have a factor. Right? So far, this is so simple. Find an upper bound, there are lots of them, for the real zeros of this polynomial. Okay, we kind of already talked about this. What are you looking to do? The polynomial is 1, -4, 2, 1. What are you looking to do? Find a number that you can put in here. And when you do the division, all of those turn out positive, right? Now, it's an upper bound. So probably we're looking at a positive number. So let's just pick one. I'll just pick 5. So here we go. 5 times 1 is 5. 5 times 1 is 5. 5 times 7 is 35. Did I find an upper bound?
Yeah.
Is it possible you could have picked another number?
7.
Would 7 have been an upper bound? Yeah. Anything bigger than 5 is going to be an upper bound. We good? Easy. Okay. List all the possible rational roots. Now, it doesn't say you're doing anything with them. It just says list them. The possible rational roots, which would be factors of 3. Now, as I'm grading your quizzes in all the classes, I'm noticing some of you are using factorials and not factors. 3 factorial is 3 times 2 times 1. 2 is not a factor of 3. A factor of 3 is a number that divides into it evenly. So the factors of 3 are 3 and 1. That's it. And the factors of 2 are 2 and 1. And that's it. So now when we make our list, and you can do just plus or minus the whole thing. You don't have to do individual pluses or minuses. But when we do plus or minus the list, we're going to have 3 and 1. That's 3 over 1 and 1 over 1. But we're also going to have 3 over 2 and 1 over 2. So there is the list of our possible rational roots. I'm going to skip number 8. I'm going to let you do that on your own. Those are review problems. And we need to get to number 9. So leave some space. 8's easy. Just FOIL it out. B is I root 7. And C, remember, you divide the exponent by 4 and look at the remainder. So leave a little bit of space on your paper. Go back and fill those in. Number 9. Solve. There are a lot of solve equations here, and there's the first one. Ideas about solving? If it factors, factoring is an option. I don't think it factors, so we'll use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. Nope, it doesn't factor. The discriminant, this guy right here, is going to be negative. So what is it? Negative. I think it's negative 31. Yeah, I'm with you on that. Negative 31. So 3 plus or minus I root 31 over 4. That is, those are your solutions. What I am trying to get you to absolutely never forget is, if the equation has a degree of 2, you can always use the quadratic formula. Don't be doing PRRs, guessing numbers, and all that. No. If it's a quadratic, you're going to do the quadratic formula, or factor it if it factors. Letter B is not a quadratic. How many answers does letter B have? Letter A had 2 answers because it was x squared. How many answers is this guy going to have? 4. Your job is to find them. Any ideas how we might start? I heard somebody say it. Take out an x squared. Absolutely. Make life easy. It's hard enough. Don't make it harder. Take out an x squared. Oh my gosh. What about that?
Negative 10.
X minus 11, x plus 1. What looks like an overwhelmingly complicated problem is a cinch. What are my answers? You're solving, so x equals 0, 11. Wait a minute. How many answers is that? 3. Wait a second, how many were we supposed to have? Anybody want to explain that to me?
That's because 1's squared.
1 squared, which means this one has multiplicity 2, which means it happens twice. Which means if we were graphing this, it would bounce off at 0. Remember, squared factors bounce off. C. This is a tricky one. I must have been in a bad mood when I wrote this sheet. I put a tricky one on here. It's actually very, very easy, but you really got to have your thinking cap on. It does factor. It factors. It factors just like this.
X plus 6. X squared plus 6.
X squared plus 6. X squared minus 1. Beautifully done. Good teamwork. Now those of you that are out there thinking, oh my gosh, I don't get this at all. Take a look. Doesn't that look like a quadratic equation? The only difference is instead of having like normally would have x squared plus 5x minus 6. That's what a normal quadratic would look like. And everybody would factor that, right? X plus 6, x minus 1. The difference is this one has the same style, but instead of plain x's, we're now going to have x squared. Which means x squared equals negative 6. Or x squared equals 1, which means x equals what?
I
Plus or minus I root 6, square root of negative 6, or x equals plus or minus 1, the square root of 1. How many answers did we get? Exactly what we were supposed to get, right? 2 of them happen to be imaginary and 2 of them are real. By the way, that is by far the fastest way to do that problem. But if you didn't see that it factored, if that's not, oh my gosh, I can't do that. Could you guess numbers and plug them in? And the numbers that you would have guessed right off the bat, hopefully, are 1 and negative 1. And when you divided those out, you'd be left with a quadratic that you could solve. So it will all work out. Don't panic. All right, what about D? We're solving D. What's going on with that one?
Factor by group.
It factors by grouping. Somebody says, oh my golly, it factors by grouping. So, let's see if we can make that happen. So we'll take out an x squared and a negative 9. And you are right, it does factor by grouping. Have an x squared minus 9 left over, which factors itself. How? X squared minus 9?
X minus 3x.
Minus 3 plus 3. Either order, doesn't matter. So what are the answers to the problem?
3, negative 3, and 2.
Yep, there they are, just exactly what you just said. X equals negative 2, negative 3, or 3. I don't know about you, but at some point, it seems like this ought to be getting harder. So far, it's pretty easy. Let's see about E.
Pretty
Maybe E's the hard one.
easy.
Directions are the same. We're going to solve this guy. don't think it factors by grouping, does it?
No.
I just want you to look at it for a minute, okay? If it doesn't factor by grouping, we're going to have to do that guessing thing, all right? Now, you can guess whatever you want. It doesn't matter. You're doing it, you guess whatever you want. But you can narrow it down. What would you narrow it down to? Factors of 2 over factors of 1. Also, this particular problem, if you look at it carefully, do you see any sign changes in this problem?
No.
Okay, now what does that mean? If there's no sign changes, there are no positive roots. Remember Descartes? So wait a second, you told me my options were factors of 2. Well, there's only 2 and 1. And now I'm telling you the positive ones don't work, so you got 2 numbers to guess. So let's try -1. Is that by any chance? Oh, there it is, right there. -1 gives me 0. So what do I do now? After I figured out that -1 is going to work, I divide it out. There's the 0 that I knew had to happen, right? Now what's left? X squared plus 3x plus 2. And what do you want to do with that?
X plus 2x plus
You can
1.
factor that. Now if you don't want to factor it, or it doesn't factor, or you can't see how it factors, you can always use your quadratic formula, right? Because it's a quadratic. All right, so what are my answers? I'm solving, so what am I going to say? X equals -1, the one I guessed has to be included, and then -2, and oh my goodness, another -1, so this has multiplicity too. We don't list the number twice. I'm not sure why, we just don't. Instead, we say it has multiplicity 2, or 3, or 4, however many times it happens. Number 9, last solve. I know we've done a lot of solving. This is the last one. All right, so here we go. We have x cubed 4x squared minus 4x minus 1. We're going to solve. Now, at first glance, you might think this one groups, but the numbers are kind of in the wrong order, so the parentheses aren't going to match up. But luckily, why does this problem kind of bring joy to my heart? There aren't very many numbers to guess, right? 1 and -1.
Yeah.
So let's see, does 1 work? Oh, right there it is. 1 works. So what do I do? Divide it out. And you're thinking, Miss, well, why are we doing this again? We just did this. And you're right. We did just do this. But this one's a little bit different. Because what comes out does not factor. So one of our answers is 1, but the other 2 answers are going to have to come from the quadratic formula. So the other 2 answers will be -5 plus or minus root 21 over 2. Everybody good with that? All right, now we're ready for number 10, which is a sketch. Oh, wait a second, is this the lunch period?
Yeah.
Okay, that's all right, don't worry. I'm gonna let you eat, but not right this moment. Now we're gonna do problem number 10, which is the sketch. We got better things to do than eat, people. We have math to do. Okay? We're gonna sketch it. Now, because we had a paper at one point that said label all intercepts, I'm gonna add that direction on here just in case that's what's on the test. Label all intercepts. Now, the x-intercepts are absolutely no-brainers. What are the x-intercepts?
-1,
-1,
2,
2,
5.
and 5. How do we get the y-intercept?
Fill in x with negative 2.
Let x be 0. Let x be 0. So if I put in zeros for all my x's, I'll get a 1 here, and a -2, and a -5. I am putting 0 in for all of my x's. That's how I find a y-intercept, because on the y-axis, x is 0. So what does that equal? -20. So obviously scale, -20, down here we go. Now, if you were gonna multiply this thing out, which you're not, but if you were, what would be the power on x? If you FOILed it all out?
It'd be 4.
X to the 4th? We say the degree is 4. X to the 4th, the degree is 4. That's an even number. What do I know about polynomials with an even degree?
They
Start up, end up.
Start down.
Unless you put a negative in front and then they start down, end down.
Yeah.
So this guy starts down here and he comes up to that point right there. Now what does he do when he hits that 0, which came from this factor right here? What does he do?
Bounces off.
Bounces down, comes down. We don't know how far, doesn't matter, just come down. Comes back up to that point. What does he do when he hits that point?
Go through it.
He goes right through it, goes up a ways, turns around, comes down to that point. What's he do? Goes through it, and sure enough, just as you predicted, you start down and end down.
So negatives are down and down.
If they're even, if they're x to the 4ths, or x to the 6th, or x squared, yes. All right, got it? Okay, let's head to lunch, and we'll do the calculator questions when you get back, and you need to be back in your seats at 12:21. 12:21. Everybody's back in your seat. Alex, would you turn that off?
Yeah.
Real quick, thank you. We don't need the videotape.